Welcome students. Before we head on to further topics, I would like to review the concepts that we have studied in the previous class. So first, let us do the review by performing some few questions, and that would be the best way. So we have a question given: sine theta is 21/29 and theta lies in quadrant 2. Then we are asked to find the value of secant theta added with tan theta. Now if you were to take the quadrants, this is the first quadrant 0 to 90, this is second quadrant 90 to 180, and this is the third quadrant. This is the fourth quadrant, 270 to 360. So in the second quadrant, only sine is positive. When I say sine along with its reciprocals, right? So definitely the reciprocal of sine is going to be cosecant theta. So cosecant theta and the sine would enjoy the positive values in quadrant 2. But when it comes to secant is actually equal to 1 over cos. Now cos is only positive in the fourth quadrant, so definitely secant will be negative, and of course tan is only positive in the third quadrant. And given the quadrant being the second quadrant, definitely secant is going to be negative and tan is going to be negative. So the value that we will have to get would be a negative of some quantity. So that is the first inference that you need to draw from this given question. So apart from that, this is a straightforward question, and this uses the concept of right angle ratios that I have introduced to you. Now this is theta, and this is opposite side, adjacent side, and hypotenuse side. And we know that sine theta is opposite side divided by hypotenuse, and we have been given 21/29. This side is 21, this side is 29. If I were to take this side as x, then clearly by the right angle ratios I can rewrite this as x squared positive 21 squared is equal to 29 squared. So from here I get 29 squared negative 21 squared. On the left it's going to be x squared. So you can multiply 29 into 29. 9 9s are 81. You carry 8. 9 2s are 18. Added with 8 will give you 26. 9 2s are 18. 1. 2 times 4, add 1 to that will give you 5. This is 1. And 14 and 8. So you have 8 4 1, and then you multiply 21 with 21. 1 times 1, 2, 2, 4, 1, 4, and then there is a 4. So this is the value that you've got, and you have to subtract this. So 8, 4, 1 and 4, 4, 1. So this is going to give you 0, 0 and 4. So this is 400. So x squared is equal to 400. X is equal to root of 400. Right, so clearly the outcome is going to be equal to 20. So I have found x is equal to 20. So from here, if I were to write my secant value, secant is, as I mentioned to you, to get secant I need to extract the value of cos. And to extract the value of cos, I got to know the formula for cos. So cos theta is nothing but adjacent divided by hypotenuse. So in this case it's going to be 20 divided by 29. So 1 over 20 divided by 29 is equal to 29. When I flip it I get 29 divided by 20. So as I mentioned to you, the value of secant in the second quadrant should be negative. So this should carry a negative sign. So let me write that down. So therefore secant is negative 29 over 20. So that's fair enough. So next comes tan theta. So let me just perform tan theta. Now tan theta is nothing but opposite side divided by adjacent side. My opposite side is 21, adjacent side is 20. But tan theta lies in quadrant 2. So tan is negative there. So the value is going to be negative 21 over 20. Now since they are asking us to get the value of secant theta added with tan theta, this is going to be negative 29 over 20 added with negative 21 over 20. LCM is 20 and 29 added with 21, 9 added with 1, 10, and then 2 with 2, 4 added with 1 will give me 50. So I get a negative sign and a 50. So we can cancel the zeros, giving us a value of negative 5 over 2. So this should be your result. So therefore secant theta added with tan theta is equal to negative 5 over 2. Now most times they will ask you a question in multiple choice and you will have this as one of the choices along with positive 5 over 2, right? Most of the times student would pick this value for the very fact that he or she would think that just by merely applying the right triangle concept, the outcome would be the accepted value. But apparently it is not so. The most important part that you will have to pay attention here is theta lies in quadrant 2. So having mentioned this knowledge point, we will move on to the next question. So let's move on to question number 2. So we're given that if secant theta added with tan theta is equal to positive 4, then the quadrant that theta lies is dash. So we are expected to find in which quadrant these two values would be lying in. So the understanding is I've got a value for secant theta, I got a value for tan theta, I'm adding them both and I'm getting a positive value. Now where can this positive value lie? So they're asking you to say this in layman term. Where is the house for secant theta and tan theta which are producing a positive value? So you got these 4 quadrants. So quadrant 1, quadrant 2, quadrant 3 and quadrant 4. Now clearly you know tan is only positive in quadrant 3. Secant is only positive in quadrant 4 over here, because secant is nothing but 1 over cos. Cos is only positive here. Apart from this that I have just shown you for tan and for secant, the question is saying that these two ratios are getting added together and they are producing a value, and it is your responsibility to house it because the value is a positive value. Now where can this value obviously be housed? Over here, because over here from the concept of cos which I just mentioned to you, cosine is positive, all ratios are positive, sine is positive, tan is positive. It is only here all ratios are positive. So straightforward, the solution is going to be quadrant 1. Only in quadrant 1 this is actually possible. Apart from quadrant 1, this is not possible. So the value for theta being equal to 4, the outcome being equal to the ratios that are producing me a positive value, for that to occur, theta should be in quadrant 1. So I mentioned that. That completes the solution to this question. But on the other hand, if they were to ask you, okay, also find the value for secant theta and tan theta, it is here you would meet up with some challenges, because we are being given only the sum, but from the sum we have to extract the individual values for the ratios. So that is going to be a bit of challenge if you are not aware of the exact algorithm that goes in. So I will mention that. Let me give you that solution. So I have given you the first solution, so this is already done. I'm going to focus on this solution. So solution, let me write down what is given. Given secant theta positive tan theta is equal to 4. Now from trigonometric ratios we know that, what do we know? We know that secant square theta negative tan square theta is equal to 1. Now we also know that a squared negative b squared can be rewritten as a negative b times a positive b, right? So from this concept I can rewrite this as, this would mean I got secant theta negative tan theta multiplied with secant theta negative tan theta is equal to 1, right? But secant theta added with tan theta is equal to 4. So if I were to take this as sum 2, so this would mean I can rewrite 2 as, in place of secant theta positive tan theta, I'm going to substitute 4. So it's going to be 4 times secant theta negative tan theta is equal to 1. This implies secant theta negative tan theta is equal to 1 over 4. Now I have taken this as 2, let me take this as 1, let me take this as 3. So using 1 and 3 we now have, using 1 and 3 we now have, what do we have? We got secant theta added with tan theta is equal to 4, then secant theta negative tan theta is equal to 1 over 4. So you add both the things together. So clearly when you do that, negative tan theta positive tan theta get cancelled, giving me 2 times secant theta is 4 added with 1 over 4, which is nothing but, I take the LCM, 4, 16 added with 1, which is nothing but 17 over 4. So from here secant theta is equal to 17 divided by 2 times 4, cross multiply, you get 17 over 8. So this is one value. So I've got the value for secant theta. So I'm going to substitute this in 1. So what happens when I substitute this in 1? So this is 17 over 8 positive tan theta is equal to 4. You move this to the other side. So this implies tan theta is equal to 4 negative 17 over 8. Take the LCM as 8. So this is 32 negative 17. So 32 take away 17. This is going to be 5. And from 2 you take away 1. So you get 15. So this is equal to 15 divided by 8. So what is this? This is my tan theta. So from here clearly you can understand, if they were to ask you the second part, then you need to do some working, right? Because the first part is a straightforward question, but the second part you need to work on. So most of the times if they were to ask you as a multiple choice, then they would also include this also, right, as a requirement. So you will have to work it out. So without working it out, you cannot guess and check. So that wouldn't give you the right answer. So having mentioned that, students, let's move on. Now this is the question involving allied angles. I already explained to you this concept. So let's write the question down. the trigonometric ratio x that satisfies the equation cosecant of 90 positive theta positive x times cos theta times cot of 90 positive theta is equal to sine of 90 positive theta. So we are expected to find that x. Now you would have been given some choices, say A is cos theta, B is some sine theta, C is some secant theta, and D is some tan theta. Some choices would have been given. You will have to go and pick up the right choice. So now let me just consider this cosecant of 90 positive theta. Now what is cosecant theta? Cosecant theta is nothing but 1 over sine theta. So this is nothing but 1 over sine of 90 positive theta. Now I already mentioned to you sine of pi over 2 positive theta. Now foremost go to the cost which I have explained to you: 0, 90, 180, 270 and 360. Now clearly this is going to be giving us a positive sign because of the presence of the argument 90 positive theta, so we can place a positive sign, and evidently we are going to be having a cos theta there. So this is a known truth. So because of this fact, therefore I can write cosecant of 90 positive theta, which I have represented as 1 over sine of 90 positive theta, is equal to 1 over cos theta. 1 over cos theta is nothing but secant theta. So I have now cosecant of 90 positive theta to be equal to secant theta. So this is the outcome for cosecant 90 positive theta. Now we also have cot of 90 positive theta. Let us go to the cos diagram. So this is 0, this is 90, 180, 270 and 360. Now 90 positive, over here only sine is positive, so cot is definitely going to give us a negative outcome. And as usual, this is 90 positive theta, so from the allied angle formula this is going to give us tan theta, so it's going to be negative tan theta, so that is also done. Now we are given sine of 90 positive theta. As I mentioned to you, 90 positive theta would put us over here in the quadrant number 2. In quadrant number 2, sine is positive, and because of the argument 90 positive theta, this is going to give us cos theta. So this is also done. So hence the given question, which is cosecant of 90 positive theta, positive x times cos theta times cot of 90 positive theta is equal to sine of 90 positive theta, can be rewritten. This is going to be secant theta positive x times cos theta. This is going to be negative tan theta. This is going to give me cos theta. Secant theta is 1 over cos theta plus x times cos theta. I'm going to write tan theta as sine theta divided by cos theta. So that would mean cos can be cancelled, giving me cos theta. So this implies I now have 1 over cos theta plus x times cos theta. Of course there is a negative sign here, so let me place that over there. On the right hand side I have no, this is actually sine theta, right? So you got a sine there with a negative sign, and I got a cos theta. So what I'll do, I'll bring this side and move this to the other side. So that would give me 1 over cos theta negative cos theta is equal to, negative would become positive, so it's going to be x times sine theta. Now I can clearly take the LCM as cos theta. That will give me 1 negative cos square theta is equal to x times sine theta. Now 1 negative cos square theta is sine square theta divided by cos theta is equal to x times sine theta. I can cancel a sine, so this is going to give me sine theta divided by cos theta is equal to x. Therefore x is equal to tan theta. So if you were to look into the choice, this is actually choice number D. Okay, that should be the solution for this question. Of course, this question can be done within a minute, but since I need to explain this, I have taken a little bit lengthier duration in placing the elaborate result. So the next question is an interesting question. So let me write the question down. Question number 4. So it states the following: the general value of theta satisfying sine theta is negative 1 over 2 and tan theta is equal to 1 over root 3 is what? They want this. So we have been given the following choices. Choice A is a 2n pi positive pi over 6, an element of integers, and choice B, n pi positive pi over 6, an element of z. C, 2n pi positive 7 pi over 6, an element of z, and D, n pi positive 7 pi over 6 with an element of z. Right? So remember, z stands for integers, set of integers, set of all integers. Right? It has to be represented as z. I have seen somewhere where people are representing it as I. This is incorrect. You can't represent the notion of integers representation from z to I, because this has a different representation. So make sure that n is represented in this fashion, right? Because mathematics is a language, as I always mention to you, and we need to stick to the rules and the laws. So we can't give our own, representations. So I will mention this because each of these representations are associated with the person who has found that out, right? So you can't take away and nullify the contribution made by these people. So, and also these are all established standards that has to be followed. Okay, so having mentioned that, let me move on. Now you have been given a question in this fashion and you got a list of choices. And foremost, before we can go on, let us observe these choices. This is 2n pi positive pi over 6, and pi over 6 stands for 30 degrees, right? And 7 pi over 6 stands for 210 degrees. Now you got n pi and 2n pi. Now you would be prompted to make a choice with this being as one of the selections, n pi positive pi over 6, right? Now we will have to examine this first. Now let me write down these values. Say I start with n pi positive pi over 6. Now if I were to take n is equal to 1, then the value is going to be 180 added with 30 degrees, right? And that can be taken as an argument, and we can take this argument for tan of 180 positive 30. So that means, let me use this diagram. So 0, 90, 180, 270 and 360. So tan of 180 plus 30. So this is 180 and it ends up over here. So that looks a good choice because tan 30 is positive 1 over root 3. That looks good. Now this is going to be equal to tan 30, which is equal to positive 1 over root 3. And if I were to take this same value for sine of 180 positive 30, this is going to give me, over here its sign is negative, and it's going to be sine 30, I get negative 1 over 2. So this is okay, but there is one problem. This has to be true for all values of n element of z. Now if I were to take n is equal to 0, then I would end up with producing pi over 6, and pi over 6 is nothing but 30 degrees, and if I were to substitute in tan 30, that's going to give me 1 over root 3. That is fine. But the same pi over 6, when I substitute it for sine, this is going to be sine 30, and that is going to be producing me positive 1 over 2, which is a contradiction to the question, right? So clearly this has to be dropped. You understand the argument that I'm coming at? So this cannot be true for all values of z. So that is the reason I am dropping this value out. So this value goes off. Now let me just move up and show you one more case. Now let me just consider n pi positive 7 pi, this one. So I'm just placing it here, n pi positive 7 pi over 6. Now I'm going to take the value for n to be equal to 1. And when I take the value n to be equal to 1, this would give me 180 positive 7 pi over 6. Now what is 7 pi over 6? That's nothing but 210 degrees. Now if you were to add these two, you would get 390 degrees. Now let me go and show you where exactly 390 degrees is. Now clearly, if you were to apply the concept which I've taught you, since it goes beyond 360 degrees, if you were to subtract this, say, let me show that to you, 390 negative 360, this is going to give me 30 degrees. So clearly I can find the value for 30 degrees. So that would mean tan 30, that's 1 over root 3, and sine 30, that's going to be positive 1 over 2. The value is found, but the question is, they are signs. That is where the complication comes. So let me just show you where exactly 390 degrees is located. Now you start here, 360 degree will land you up in one spin, right? Plus you have to add 30 degrees, right? This is actually 360 plus 30. That is what is going to give you 390. So if you were to add 30 degrees, that would take you to the first quadrant. Now in first quadrant, all ratios are positive. So sine 30 would be producing you 1 over 2, and tan 30 would be producing a positive 1 over root 3. But there is again a contradiction to the given value. So this should also be dropped. So I've already shown you why this is dropped. Now I'm showing you why this is dropped. So now all that we have left with choice A and choice C. So you will have to select which of these two choices is going to be the solution. So let me now take choice A and show it to you. Now choice A is given to be as 2n pi positive pi over 6. Now let me take the value for n to be equal to 0. The moment I take the value for n to be equal to 0, I would get 30 degrees. Now tan 30 produces me, tan 30 would give me 1 over root 3, that's fine. But the problem will be sine 30. Sine 30 is giving me 1 over 2. As I mentioned to you, this contradicts the given value. So clearly we cannot take this. This is dropped. Now the only set of values, or I would say the last remaining warrior that would have to be tested, is going to be the quest. So we have been given 2n pi positive 7 pi over 6. So let's check if this warrior is going to be qualifying. If he qualifies, then hats off. Now first and foremost, what I would like to do is I would like to assign n to be equal to 0. That's the basic check. Now if I were to take n is equal to 0, I would get 210 degrees. Now just go and examine where 210 degrees is falling. So if I were to start here, this is going to be 180 and 210 will land me up over here. Over here, sine is negative. Sine theta will give me a negative value. So clearly, this is our choice. Because if we were to write this as sine of 210 degrees and go up and rewrite this as sine of 180 positive 30, 180 positive 30 will land us up in the quadrant 3. And quadrant 3, sine is negative. So that's going to give me negative sine of 30 degree, which is negative 1 over 2, right? That's the value, negative 1 over 2, which concurs with the value given in the question. And so therefore the choice is this 2n pi positive 7 pi over 6. Of course this question needs some detailed understanding, so that's the reason I was a little bit elaborate, because it is imperative that students understand why this is the scenario and how to reach this scenario. Because I do not believe in giving displayed slides and then explaining it, because that wouldn't stimulate the creativity of the individual, because studies have shown that PPTs are basically not increasing the creativity, because the brain, when it sees these so-called PPTs, it gets stuck. So there is no way that the brain is allowed to expand and extrapolate the ideas. So that is the reason, if you want to do mathematics, you will have to use either chalk and talk, or you should get a good notebook and practice and practice and practice. Let's do this question, students. This question uses the concept of compound angles. So we will be applying compound angles, which I've already explained to you in the previous class. So the question is as follows. It wants us to find the maximum value for this expression, 1 positive sine of pi over 4 positive theta positive 2 times cos of pi over 4 negative theta, right? Now let me just consider 1 positive sine of pi over 4 positive theta positive 2 times cos of pi over 4 negative theta. Now I'm going to use sine of a positive b formula, which is nothing but sine a cos b positive cos a sine b. And then I would be using cos of a minus b formula, which is cos a cos b is negatives here, so it's going to be positive sine a sine b. So if I were to take this as 1, therefore I can rewrite 1 as 1 positive sine pi over 4 cos theta positive cos pi over 4 sine theta positive 2 times of cos pi over 4 cos theta positive sine pi over 4 sine theta. This is equal to 1 positive sine pi over 4 is 1 over root 2 multiplied with cos theta. Cos pi over 4 is 1 over root 2 multiplied with sine theta positive 2 times of cos pi over 4 1 over root 2 cos theta, 1 over root 2 sin theta. So this is equal to 1 positive. I can take root 2 out, 1 over root 2 out. That would give me cos theta positive sin theta. I can take 2 over root 2 cos theta positive sin theta. So I got a cos theta positive sin theta. Now if I were to take that out, this is going to give me cos theta positive sin theta of 1 positive root 2 positive 2 over root 2. So this is what I have got. Now what I wish to do is I would like to actually write this 2 as root 2 times root 2, so that this can be rewritten as 1 positive cos theta positive sin theta times 1 over root 2 positive root 2 into root 2 divided by root 2. So I can cancel it off, and thereby I will now have an expression in this fashion: 1 positive cos theta positive sin theta times 1 over root 2 positive root 2. So this is what we have got. Now what we need to do is we need to perform some manipulation for this cos theta positive sin theta. So what I will do is I will multiply this by root 2 and I divide this by root 2. So if I were to do that, I can rewrite this to be as 1 positive, I'm going to take root 2 out, I'm going to rewrite this as 1 over root 2 times cos theta positive 1 over root 2 sin theta multiplied with 1 over root 2 positive root 2. So this is what we have got. Now this is equal to 1 positive root 2 times, now 1 over root 2 I can have that as sine pi over 4 times cos theta. Now 1 over root 2 I can have that as cos pi over 4 sin theta times 1 over root 2 positive root 2, right? This is what I've got. Now what is this? I would like to rewrite this entire component in this fashion: 1 positive 1 over root 2 positive root 2 times root 2 of this entire thing can be rewritten as sine of pi over 4 positive theta, right? Now the question wants us to find out when will this produce a maximum value. This has to give us a maximum value. Now we all know the range of sin theta, right? And given that information, also we know the ranges of sin theta, cos theta, because those are the two trigonometrical ratios which are pertinent here. Now clearly we have sine of pi over 4 positive theta. Now this has to hit the maximum, right? This has to produce the maximum, and the maximum produced, or I should say the maximum value that sine is capable of producing is 1. So it has to reach 1. Anything less than that would not be sufficient enough for us to achieve our goals. So sine has to hit its maximum value. So that is the understanding that you will have to apply here. So why do we do that? Because our objective is to produce a maximum value for this expression. And as I mentioned to you, that is only possible if this trigonometrical ratio sine hits its maximum value. So that is going to be 1. That's all. This problem is solved. So 1 positive, just distribute root 2 inside. So it's going to be root 2 divided by root 2. Root 2 times root 2 will give you 2. So there's going to be 1 positive 2, which is going to be 4. So this should be the value. 4 will be the solution. So usually they might put this question in multiple choice. They may give you the following choice: A is 2, B is 3, C is 4, and D is 1, something like that. So your choice should go to C. So this is the maximum value that is being produced. So that is going to be the review for all the concepts that we studied in lecture 1. So now we are heading on to do questions, or I should say understanding the concept of trigonometric equations. So this is the start of the lecture. So students, let's start with trigonometric equations. So this is the second lecture and a new topic. So how do we define this concept, trigonometric equation? In simple terms, an equation consisting of trigonometric functions. It can be functions, it can be ratios, separated by equality. Sign is called a trigonometric equation. So this is the crude definition, right? Example, we can have something like this: tan x positive sin x is equal to some alpha. I'm not specifying the value. Anything, it can be tan x, it can be cot squared x or cot squared, some value alpha negative sine squared alpha is equal to, say, some value a over b, something of this fashion. So the usual order or the usual representation is you should ensure that there is an equality here. If there isn't the equality, or I should say, if you are not able to find the presence of an equality sign, then we are not dealing with the equation. So trigonometric equation is made up of two words: trigonometry plus equation. So you need to have the equality sign. So without the equality sign, if they were to give you some question like this, so they're asking you, is this a trigonometric equation? And they give you like this, say sine theta plus cos theta. The answer is no. This is not a trigonometric equation. No. Right? So on the other end, if they are giving you something like this, say sine theta negative cos square theta is equal to 2. Is this a trigonometric equation? The answer is yes. Simple as that, right? So we will do some questions. The best way to understand a concept is to do questions. Now, one good thing about trigonometric equation is that the understanding of the concepts have already been achieved in lecture 1, followed by a series of examples which I've just given you as review at the start of this chapter. So this chapter is not a difficult chapter. So let's get it started. Now the next important concept you will have to know is what is expected of you. So what is your objective whenever you are solving a trigonometric equation? So this is very important, right? You need to understand what is expected from you. That is the purpose of giving you that question. So if you're not able to understand what is expected from you, then how are you going to solve the question? Because of the very fact, say for example, this is a question posed to a data scientist. So a certain company, it sends out for an interview, and the position is data scientist. So after shortlisting one particular person, right, the boss of this company calls this person for the interview, right? So there is this interview for this data scientist. The boss is very impressed with this person's performance, so he gives him a data cluster. So data cluster is nothing but a series of data set, and tells him to analyze analyze the data set. So immediately the data scientist, right, poses the question back to the boss. Right, so let me just draw these two people here. So you got the boss here and you got the data scientist. So the question comes back to the boss. The question is, you're asking me to analyze, what do you want to know? What do you want to know? The boss immediately tells him, look, that's why I have given you the data set. So you analyze and tell me, what exactly should I know? Are you following the pattern here? Let me reiterate. The boss gives this guy, he wants to employ this data scientist. And so he gives him the data set and tells him, analyze. The data scientist looks at the data set and tells him, what exactly do you want to know? And the boss tells him back, that is the reason I'm going to employ you. What am I supposed to be knowing from the data set? So there is a circle that would eventually start here, a spiraling circle. The question from the boss to the data scientist and the data scientist giving back the question, and it would never end at all. So the point I wish to emphasize here is the boss in its, or the approach followed by the boss, might be correct, but from the perspective of the data scientist, it is highly flawed. Because you walk into a doctor's office, unless you tell the doctor what is the issue or the concern that is plaguing you, the doctor wouldn't be in a position, he wouldn't be in a position to understand what is exactly tormenting you or disturbing your sleep, right? You cannot simply go to the doctor and say, can you analyze what's my problem? In fact, nobody, no science or technology that is existing out there can be in a position to tell what is exactly happening in an individual's body. So because that is the way things are actually geared up. So why am I taking this time in explaining to you? Everything would have been sorted out in this boss and data scientist case if the boss would have told the data scientist what he is looking for in the data set. There is a huge haystack, right? You got a huge haystack. Nobody knows what you have lost in the haystack unless you tell the person that you have lost a spade or a jewel. Because the brain is such a powerful organ that immediately it will visualize that particular missing object and search for it, designing its own algorithm with it. So, having mentioned this illustration, to solve a trigonometric equation, you have to first understand what you are looking for, or someone have to tell you what you should look for. What you should look for. Simple as that. So that's why I'm just telling you what you should look for. You should look for the value of the unknown. What unknown? Angle that satisfies the equation. What equation? Trigonometric equation. Right? So this is your objective, finding the unknown angle. So having mentioned that, let's move on. Let me give you this illustration for better understanding. Solve sine theta is equal to 1 over 2. Now the unknown angle here is theta, and you're expected to find the values of theta. If you were to solve this, clearly you can see that theta can be 30 degrees, theta can be 150 degrees, theta can be 390 degrees, and so on and so forth. Now, if you were to be given some restrictions, so based on the restrictions, you can limit these values, and that would be the solution. If they were to give you the restrictions, you can pick up these values and state the solution. If no restriction is given, this should be the solution for this particular equation. So that is the best illustration to understand trigonometric equation in brevity. But that wouldn't be sufficient enough to cover the topic. So we will have to do examples after examples so that you get a better understanding of the topic. Now, additionally, there are a few important things that you will have to know. Now, if sine theta is equal to 0, then the value of theta will be equal to n times pi, where n is the element of z. So, for all values of n present in z, theta equal to n pi would satisfy this equation. So that is the first point that you will have to know. Point number 2, if you were to take cos theta is equal to 0, then theta would take all values of the form 2n positive 1 times pi over 2 for n element of z. So in this case, n can take any values present in the set z. So have this in mind, and these two are very important concepts. So if you were to list out the values for sine theta, with theta being equal to 0, pi, 2 pi, 3 pi, 4 pi, and so on and so forth, sine is going to be producing 0 here, sine pi is going to be 0, sine 2 pi is going to be 0, sine 3 pi is going to be 0, sine 4 pi is going to be equal to 0, and so on and so forth. So this is for sine. So that's the reason I have just placed theta is equal to n times pi. Now if you were to take the value for cos theta, and theta is equal to, in this case I take n is equal to 0, the first value that I would get is pi over 2, and then n is equal to 1. This is going to give me 2 added with 1, 3 pi over 2, and this is going to produce, for n is equal to 2, 5 pi over 2, and n is equal to 3 times 2, 6, 7 pi over 2. So n is equal to 4, 8, positive 1, 9 pi over 2, right? For all of these values, cos pi over 2 is 0, cos 3 pi over 2 is 0, cos 5 pi over 2 is 0, cos 7 pi over 2 is 0, cos 9 pi over 2 is 0, and so on and so forth. So this is the value that would be the outcome when theta takes the value 2n positive 1 of pi over 2. So this is clearly visible from the graph, right? If you were to draw the graph of sine 0 is 0. It starts here. Let me show you that. It starts here, then at pi over 2 it will hit 1. So this is the maximum value that sine will take. So at pi over 2 it hits 1, and then at pi it will just come down. It will hit 0. Of course, if I were to stretch the graph, it goes like this, and subsequently at 2 pi the graph actually goes down, and at 2 pi it will rise up, and exactly at 2 pi it will hit the point 0. So this is a point 0, and this would be occurring even for the negative side of the axis. This is the positive side. For negative side, subsequently you will have the curve being repeated in the manner that I've shown you. right? So on the negative end, it's going to be negative pi, negative 2 pi, negative 3 pi, negative 4 pi. So the same graph would be occurring there. So having mentioned that, that's fine. Now, if you were to draw the graph for cos, right? Now cos of 0 is equal to 1. So cos it's 1 at this particular point. Now exactly at pi over 2, right? At pi over 2, cos will hit the point 0. Of course, cos pi will produce us a negative value, so it goes down all the way here, right? And exactly at 3 pi over 2, so this is going to be 3 pi over 2, it will rise up and hit this particular point at 0. And of course at 2 pi, cos 2 pi will be hitting positive 1 exactly over here, and then at 5 pi over 2 it will come down to hit the point 0. So this is the graph for y is equal to cos x, this is the graph for y is equal to sin x. So I've just shown you how the wave is occurring. So having got that, let's move on. I would like to take this to be an example. Sin theta is equal to 1 over 2. If we were to draw the graph of sin theta is equal to 1 over 2, there are two parts here. One is left hand side and right hand side. First, let me draw the graph for sin theta. Say y is equal to sin theta. So that graph would be roughly in this fashion. Alright, it would be a wave, right? Now, if I were to draw the graph for y is equal to 1 over 2, then that would be a constant line. Okay, this is the rough graph. Now, if I were to ask you, find the point of intersection of the line y is equal to 1 over 2 versus the curve, sine curve y is equal to sin theta, what would you say? You have a point of intersection here. Let me use this pen. You got a point of intersection here, 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 and that subsequently you're going to have infinite number of points of intersection of y is equal to 1 over 2 versus y is equal to sin theta, right? So if I were to ask you, find all the points of intersection, that is called as the general solution. Have that in mind. So what is the meaning for the general solution? If someone were to ask you, find all of these points of intersection. Clearly we know there are infinite set of points where y is equal to 1 over 2 is intersecting with the curve y is equal to sin theta. So to get all of the solutions is called as a general solution. Number 2, there is another solution that is called as the principal solution. Now what is the principal solution? Principal solution is to obtain all of the solutions that are given in the interval 0, 2 pi. So this is a very important understanding, because in all of the questions you will either be asked to obtain the general solution or the principal solution or both. So just to reiterate, the principal solution is found in the interval, closed interval 0, open interval 2 pi. Right, and the general solution is nothing but to obtain all of the intersecting points of, in this case it's y is equal to 1 over 2 and y is equal to sin theta. So that is what is of critical importance in understanding trigonometric equations. So having mentioned that, let's move on, students. Okay, students, having defined the two terminologies, the general solution and the principal solution, the most important question now is, how are we going to obtain the principal solution? Say for example, for sin theta is equal to 1 over 2. Now if we were to consider the graph, now clearly there are 2 points of intersection here. So as I mentioned, there is a point of intersection here, there is a point of intersection here. and the graph is flowing from 0 to 2 pi. This point is going to be 2 pi, right? We already know that. So between 0 and 2 pi, there are 2 points of intersection. Now clearly we know that when sine theta is equal to 1 over 2, theta value is going to be pi over 6. So this value, this point of intersection is going to be pi over 6. Now the next important question is, what would be this value? In other words, what would the value of theta be for this point of intersection? Now clearly we know that it's going to be 5 pi over 6. Now the question comes is, what if they would have given us, instead of the sine curve, they would have given us some other function? How are we going to extract the value of theta? Because it is imperative that we obtain the value of theta. That is obviously the principal solution, right? The point of intersection. But if in case we were to encounter functions which aren't too familiar, then extracting the point of intersection would become a challenge. In other words, extracting the value of theta would become a challenge. That would be at times a little bit tougher to crack. So what I wish to do here is, I would like to give you an alternative technique without the use of graphs to obtain the principal solution. Now foremost, this particular method has got 3 steps. Now the first step is, whatever be the equation given to you, take the modulus sign and then write that as sine alpha. Okay, so mod of 1 over 2 is going to be positive 1 over 2. Now step 2 is, find out where exactly this particular value is located. In other words, in which of these quadrant. Now clearly I mentioned to you that we use the concept of cast, C-A-S-T. All ratios are possible, sine alone is positive. When I say possible, it means positive. So in the first quadrant all ratios are positive, second quadrant only sine is positive, third quadrant tan alone is positive, and in the last quadrant cos alone is positive. When I say cos, it means their respective reciprocals also will be positive here. Now clearly if sine alpha is equal to 1 over 2, it's a positive sign here, and that is possible only in the first quadrant and in the second quadrant. Okay, so that has been zeroed in. So in step number 3, the values, it is imperative that you know this, you have this in the corner of your mind. The values that theta would take would be given as follows. In the first quadrant, theta takes alpha. In the second quadrant, theta takes pi minus alpha. In the third quadrant, theta takes pi positive alpha. In the final quadrant, theta takes 2 pi negative alpha. So this is important. Now clearly we know that sine alpha is equal to 1 over 2, which is positive, and that occurs in the first quadrant and in the second quadrant. So if I were to write the solution, okay, clearly the principal solution, okay, for sine theta is equal to 1 over 2 is alpha and pi negative alpha. Okay, but clearly we know that alpha is equal to pi over 6 because sine 30 is equal to 1 over 2. So this is going to be pi over 6, and in this case it's going to be pi negative pi over 6, which is equal to 6 pi negative pi over 6, which is 5 pi over 6. So therefore the principal solutions are pi comma 5 pi over 6. Okay, so I have extracted the value of theta even without the use of graphs. Let's do another question, students. So we are given in this case sine theta is equal to negative 1 over 2. So step 1, according to step 1, we take the modulus of this value negative 1 over 2 and write it in this fashion: sine alpha is equal to 1 over 2. Now step number 2 is to find out where exactly we would get 1 over 2, and the sign has to be negative, right? So if I were to represent this by the popular cast, C-A-S-T, sine is negative in the third quadrant and in the fourth quadrant, right? So step number, let me write that down here. Step number 3 would be to write that popular quadrant for theta. Now theta takes alpha here, over here it takes pi negative alpha, over here it takes pi positive alpha, over here 2 pi negative alpha, right? So since the value of sine is negative in the third quadrant and in the fourth quadrant, the principal solution is pi positive alpha and 2 pi negative alpha. But what is alpha? We have taken alpha value to be as, in fact, sine alpha is equal to 1 over 2. So alpha is going to be 30 degrees. So this is going to be pi positive pi over 6, which is nothing but 6 pi positive pi over 6, which is equal to 7 pi over 6. Now for this, it's going to be 2 pi negative pi over 6, which is equal to 12 pi negative pi over 6, which is equal to 11 pi over 6. So therefore, the principal solution is going to be 7 pi over 6 comma 11 pi over 6. So that is the solution, students. Secant x is equal to negative 2, right? And we are expected to find the principal solution. Now cosecant x is equal to negative 2, so this would imply 1 over sine x is equal to negative 2. Therefore sine x is equal to negative 1 over 2. So this is the understanding. So step number 1, we take the modulus of this and write it as sine alpha is equal to 1 over 2. Now step 2, you will want to locate the quadrant where sine x is equal to negative 1 over 2 occurs. In other words, where exactly sine occurs in a negative fashion, or in which of the quadrant sine becomes negative. So however you want to represent, you can make the representation. So clearly, if we were to apply the cast measure, we know that sine is going to be negative in the third quadrant and in the fourth quadrant. So having got that, let us go to step number 3 and find out the values that theta can take in these quadrants. In the first quadrant, theta takes alpha, or in this case x will take alpha. Second quadrant is going to be pi negative alpha. Third quadrant is going to be pi positive alpha. The fourth quadrant is going to be 2 pi negative alpha. Now clearly we know, since I've taken sine x is equal to modulus of negative 1 over 2, which is nothing but 1 over 2, we are actually dealing with theta to be equal to, or in this case alpha value is going to be pi over 6. Okay, so alpha is equal to pi over 6, because pi over 6 is nothing but sine 30, and sine 30 gives us 1 over 2. So therefore the principal solutions are going to be the third quadrant and the fourth quadrant. So that would be pi positive alpha and 2 pi negative alpha. So if I were to substitute the value of alpha, I would get pi positive pi over 6 comma 2 pi negative pi over 6, which can be rewritten as 6 pi positive pi over 6 and 12 pi negative pi over 6, which is equal to 7 pi over 6 comma 11 pi over 6. So this is our principal solution. Students, now it's time for us to obtain the general solutions. Now when sine x is equal to sine alpha, then the general solution is given as x is equal to n pi plus negative 1 raised to the power of n times alpha. Similarly, when cos x is equal to cos alpha, x is given to be 2 times n times pi plus or minus alpha. When tan x is equal to tan alpha, x is given to be as n pi plus alpha. Now subsequently, when sine squared x is equal to sine squared alpha, cos squared x is equal to cos squared alpha, and tan squared x is equal to tan squared alpha, the general solution is given to be as x is equal to n pi plus or minus alpha. So it's important that you have this in mind. Here you get only plus, over here you're getting plus and minus. So have that in mind. To understand this concept, let us do a question. Imagine we are asked to obtain the general solution for tan squared x is equal to 1. Now before I could give you the solution, please do not write this as tan x is equal to root of 1. Don't do that, because you will end up with a solution that is contradictory to the very fact that tan squared x is equal to 1. So having mentioned that, so this is a no action. So we are given tan squared x is equal to 1 and we are expected to obtain the general solution. So what I would be doing, I would be rewriting tan squared x equal to 1 to be as tan squared of pi over 4, right? Pi over 4 is nothing but 45. So tan 45 is 1. Tan squared of that particular value, 45, will still be equal to 1. So I'm not doing anything different. Now this is similar to the one that we have studied. So you can clearly write that this is similar to tan squared x is equal to tan squared alpha, where the general solution is given to be as what? X is equal to n pi plus or minus alpha. So if I were to write here the general solution, hence the general solution is x is equal to n times pi plus or minus, what's the value of alpha here? Pi over 4, where n is an element of integers. So that is the solution. To be more precise, the general solution for the given question. It states that sin x is equal to 0 and we are expected to solve. This is a trigonometric equation. Now for this equation there would exist, as I mentioned to you earlier, there are two solutions for this. One is called the principal solution and the other one is called the general solution. Now for the principal solution to exist, the interval has to be given, whereas in case of general solution, the name itself states it is a general solution. You don't have to specify the interval. So in this case you got sin x is equal to 0. Now suppose they had given you find all x such that x is contained in the interval 0, 2 pi. If this were to be the question, clearly they have specified the interval. Now if you were to look into the graph of sin x, you can clearly see sin x starts at 0 and ends at 2 pi. So this is exactly for all x contained in the interval 0, 2 pi. Now if you were to write down the solutions, clearly you can see that at x is equal to 0, sin x hits the origin at 0. Again at x is equal to pi, sin x hits 0, and then at 2 pi, sin x hits 0. So the solution for this would be x is equal to 0 and then x is equal to pi, and then followed by x is equal to 2 pi. So this is going to be my solution set. This is called the principal solution. If you were to see the sin x graph, the sin x graph is actually an infinite graph. It continues. It just rises up again, and then it hits, and then it flows, right? So there is no stoppage for that particular progression. So in that case, we need to obtain the general solution. So for general solution, what we do is, we know that if sin x is equal to sin alpha, then the general solution is given as x is equal to n times pi plus negative 1 raised to the power of n times alpha, right? Now the question states that sin x is equal to 0. Now what I wish to do is, I would like to rewrite this right hand side 0 as sine of 0. So clearly this would mean my alpha is equal to 0, right? Because sine 0 is going to be 0. Now where do I get the alpha from? The first value that produces sin x to be equal to 0. So in this case, x is equal to 0 is basically producing me 0. So that's why I'm just taking that value to be alpha. Now since I've got alpha, therefore the general solution is going to be x is equal to n times pi positive negative 1 raised to the power of n. Alpha is equal to 0, so place the 0. So 0 multiplied by anything would give me 0, eventually leaving me with x is equal to n pi, which is the general solution. So that is how you obtain the general solution for this particular question. So I've got the principal solution as well as the general solution. So that would be the conclusion for this question. So we'll move on to the next question. This is a nice question. Question number 2. Solve 2 times sin x negative 1 is equal to 0. So this is a trigonometric equation, and we are given this 2 times sin x negative 1 is equal to 0. So foremost, what I wish to do is, I would like to just consider this. Consider 2 times sin x negative 1 is equal to 0, because usually this is how we start the solution from the problem. Now I would move negative 1 to the other side. So this would give me 2 times sin x is equal to positive 1. Bring the 2 down. So I get sin x is equal to 1 over 2. This is the positive value. Now if you were to go to the quadrant, which I've mentioned to you in the previous class, 0 to 90, this is 180, and 270 and 360, right? So over here, alpha, all ratios are positive. This is going to be pi minus alpha, and this is going to be pi positive alpha, and this is going to be 2 pi negative alpha. So first quadrant, all ratios are positive. Second quadrant, only sine is positive along with this reciprocal. Third quadrant, tan is positive along with this reciprocal. So now we have got sin x is equal to 1 over 2, which is nothing but it's a positive sign there. So sin x is positive over here, so that would mean I can extract theta here or x here, and in this case I can also extract the value of x from here. Now this is going to be sin x is equal to, now when exactly would we get 1 over 2? If this is going to be 30 degrees, right? So I have clearly written sin x as being equal to sin alpha. This would mean alpha is equal to 30 degrees, which in case is going to be pi divided by 6. So I've got the alpha here, so pi over 6 is there, and to get the next value we need to subtract pi negative alpha. Okay, this is the next angle, so this is going to be pi negative pi over 6, which is going to be 5 pi over 6. So I've got a pi over 6 and a 5 pi over 6. So the principal solution being pi over 6 comma 5 pi over 6. So that is the value. So we can place them in parentheses, and now it's time for us to write the general solution. So if sin x is equal to sin alpha, then x is equal to n times pi positive negative 1 raised to the power of n times alpha. Now my alpha is pi divided by 6, so this is equal to n times pi positive negative 1 raised to the power of n times pi over 6. So this is my x value, and you can state GS or general solution general solution. Right, so this is the completion for this question. It's a lovely question, and we will move on to the next one. Let's take question number 3, students. We've been given root of 2 times cos x negative 1 is equal to 0. And we are asked to solve this trigonometric equation. So foremost, let me start off by consider root of 2 times cos x negative 1 is equal to 0. So I'll move the 1 to the other side. This in turn would give me root of 2 times cos x is equal to 1. From here I can rewrite cos x is equal to 1 over root of 2. So cos x is positive. So I can write cos x as cos alpha, which is possible because of the fact cos x is being equal to 1 over root 2, which is nothing but cos 45 degrees. So this would mean alpha is equal to 45 degrees, which can also be rewritten as pi divided by 4. Now if you were to draw the cos diagram, 0, 90, 180, 270 and 360, alpha is over here. It means all trigonometric ratios are positive. Over here pi negative alpha, only sine alone is positive. Over here pi positive alpha, tan alone is positive. Over here 2 pi negative alpha. So cos is positive here along with this reciprocal. So it's also positive over here, positive over here. So therefore the solution set is going to be pi divided by 4, that's fine, followed by 2 times pi negative pi divided by 4. So what is this? 4 times 2 is going to give me 8 pi over 4 negative pi over 4, which is rewritten in this following fashion. Which is going to be 7 pi over 4. Now cos 7 pi over 4, just to give you some additional information. Now we know that cos pi over 4 is nothing but cos 45, right? Cos 45 is 1 over root 2. This is actually trivial because of the fact that we know the value. Now cos 7 pi over 4 is nothing but cos of 315 degrees. Now this is also equal to 1 over root 2 because of the fact that we have achieved the value, because of the understanding that we have of the quadrant. So that's exactly what I wish to draw your attention to. Now the general solution is different. Now since we have cos x to be equal to cos alpha, the value of x is given as 2n times pi plus or minus alpha. This is the general solution. So if you were to rewrite this for the first value, pi over 4, x is going to be equal to 2 times n times pi plus or minus pi over 4. So this is the general solution. So that is the solution for this question. Now students, let's do the next question. Question number 4. We expected to solve this question given that tan x negative root of 3 is equal to 0. Let me just start off by considering the given question. Consider tan x negative root 3 is equal to 0. If I were to move this root 3 to the other side, this would give me tan x is equal to root of 3. Now this is actually root of 3 over 1. Now this is produced when x is equal to pi divided by 3. So that means when x is equal to 60 degrees or when x is equal to pi over 3. Right? So we got the value pi over 3. Now if we were to draw the quadrant, let me just show you the quadrant which I have already drawn. I got alpha, pi negative alpha, pi positive alpha, 2 pi negative alpha. Tan is positive in the third quadrant as well as in the first quadrant. So So the values are alpha and pi positive alpha. So that's the principal solution. So therefore the principal solution is going to be alpha comma pi positive alpha, which is equal to pi over 3 comma pi positive pi over 3. So this is equal to pi over 3 comma 3 times pi positive pi, that's going to give me 4 pi over 3. So principal solution is done. Now to obtain the general solution, when tan x is written as tan alpha, or instead of saying, it's up to you, you can say when or use the term if. Okay, then x will be equal to n times pi positive alpha, there's no plus or minus, where n is element of z. Now in all these cases, whenever you see n, it's by default element of z, set of integers. So use the letter z. Okay, so that is the solution. So this would mean the general solution is going to be n times pi positive, use the first angle pi over 3, and that is the solution for the question. To find the general solution for sin x is equal to negative root of 3 over 2. So first what we will have to do is, to solve this question, it comprises of 2 steps. So step number 1, we will have to find the principal solution, and step number 2, we will have to then head on to find the general solution. Now let's execute step number 1, that is finding the principal solution. So to find the principal solution, we have got 3 steps, right? For the first step, what we would do is we would take the modulus of this quantity and write it as sine alpha is equal to root of 3 over 2, right? Now what would be the value for alpha here? Now clearly sine 60, right? Sine 60 is going to be root 3 over 2. So alpha is pi divided by 3, right? So having got that, next step number 2, we will have to know when exactly or where exactly sine takes the negative value. So if I were to apply the cast concept, C-A-S-T, sine is negative in the 3rd quadrant and in the 4th quadrant. So that will take us to step 3, where the first quadrant takes, where theta takes the value alpha, 2nd quadrant is going to be pi negative alpha, 3rd quadrant pi positive alpha, final quadrant, 4th quadrant is 2 pi negative alpha. Since we are basically concerned with the 3rd and the 4th, the principal solution in this case is going to be pi positive alpha and 2 pi negative alpha. So this would mean pi positive, the alpha is pi over 3, and 2 pi negative pi over 3, right? So this is going to give me 4 pi over 3 and 6 pi negative pi, that's going to be 5 pi over 3. Now take one of these values. So clearly we can say that therefore this implies the principal solution is found to be as 4 pi over 3 comma 5 pi over 3, right? So that is for the principal solution. Now out of these 2 values, we can choose one of the value to be as alpha and then head on to obtain the general solution. So what I wish to do is, let me write that down, general solution. Now we know that when sin x is equal to sine alpha, the value for x is given to be as n pi plus negative 1 raised to the power of n times alpha, right? So that would mean my sin x in this case is going to be sine of, I've taken alpha to be as 4 pi over 3. So this is going to be sine of 4 pi over 3. Now sine of 4 pi over 3 is obtained because of the principal solution we have just received, or in other words, we have just achieved. So I'm just taking one of these values. Now having obtained this, clearly we can hence obtain the value for x, which is going to be n times pi plus negative 1 raised to the power of n times 4 pi over 3. Now what is this? This is the general solution. So clearly you can put this in a box. So that is the solution for this beautiful question, students. We will head on to the next one. Let's do another question, students. This question is given to be as sine squared x is equal to 1 over 4. So what I'm going to do is I'm going to write this 1 over 4 as sine pi over 6, because sine pi over 6 will give me 30, right? Sine 30 is 1 over 2, but I need to produce 1 over 4, so just square that. So subsequently this is rewritten as sine squared pi over 6. So remember, do not transfer the square to the other side and write it as square root of 1 over 4. That is not going to be working at all. So this would mean this is of the form sine squared x is equal to sine squared alpha, which would mean x is equal to n pi plus or minus alpha. So hence the general solution is going to be equal to n pi plus or minus, what's the value of alpha? It's pi over 6, right? And n is any integer, right? So that is going to be the solution, and we can box the result. So we will move on to the next question, students. Let's do another question, students. In this question we are given cot x is equal to -1. Now we haven't seen anything involving cot, isn't it? But however, we know that cot x is equal to 1 over tan x. So rewriting this, we are going to have 1 over tan x is equal to -1. Therefore tan x is equal to -1. Now to obtain the principal solution, actually the question wants us to find the general solution, right? So for that, as I mentioned to you, it involves two steps. One, we start off by finding the principal solution, and then we move on to obtain the general solution. So the steps for obtaining the principal solution is as follows. So step number 1, we take the modulus. So therefore we now have tan alpha is equal to +1. Now step number 2 is to zero in the quadrant. So we employ CAST. Now tan x is equal to -1. Where exactly tan is negative? Clearly in the second quadrant and in the fourth quadrant. Now step number 3 is clearly the possible values that theta can take in among in other words, x can take in this quadrant is as follows. Alpha, this is going to be pi negative alpha, pi positive alpha, and 2 pi negative alpha. So therefore the values for the principal solution is going to be lying in the second quadrant and in the fourth quadrant. So this would mean my alpha in this case, clearly we know that alpha is equal to pi over 4 here, right? Because that's 45. So that's going to be pi negative pi over 4 comma 2 pi negative pi over 4. So this is equal to 4 pi negative pi, that's 3 pi over 4, 8 pi and 7 pi over 4. So I will take one of these values for obtaining the general solution. So what I will do is I will take 3 pi over 4. Now we know that when tan x is equal to tan alpha, x is equal to n pi positive alpha. So this is the general solution. So in this case, this would mean tan x is equal to, I'm choosing the first value, tan of 3 pi over 4, which would mean my general solution is equal to n pi positive 3 pi divided by 4, where n is an element in the integer, in the set integers. So this is the solution for this question. Students, the next topic we would be learning is known to be as number of solutions. Right, so we would have to extract the number of solutions that are occurring in the given equation. So having mentioned that, it is imperative that you take note of this particular topic, and it is of critical importance. And having mentioned that, let us move on to do a question. Now we have been given sine 4x is equal to negative 1 over 2, and x is contained in 0, 2 pi. Right? Now a point of observation. If you were to draw the graph of sine 4x, it would be a real challenge because this is a compressed graph. So what we would be doing is we would try to convert sine 4x into sine x, because we know the graph of sine x, right? If it were to be sine x is equal to negative 1 over 2, then it would be a cakewalk for us, because the graph of sine x is well known to us, but the graph of sine 4x, to draw it would be a real challenge. So having mentioned that, what I wish to do is I would like to convert sine 4x into sine x. Now how are we to do that? So let us just start off like this. Now this is given, right? Given that sine 4x is equal to negative 1 over 2. Now the interval given for x is between 0 and 2 pi. Now what I would like to do is I would like to take the value or the coefficient of x, which is 4, and then multiply it out. And that would give us 4 times x is contained in 4 times 0 is 0, 4 times 2 pi is 8 pi. So this is what I'm doing. Now having done this, what I wish to do is I would like to now, let me write that down here. So sine 4x is equal to negative 1 over 2. So this is what I have got. Now the next step is I would like to take, let 4x be equal to theta. So if I were to take sine 4x is equal to theta, then that would mean I now have sine theta is equal to negative 1 over 2, where theta is in the interval 0, 8 pi. Right, now if you were to draw this, then the graph would look something like this. So 0 to 2 pi. So let me just draw the graph. So the graph of sine x is going to be like this. It's going to hit here and then move up and hit and then move up and then hit and then move up and then hit and then move up. Right, so let me give the coordinates now. So this is going to be 2 pi and then 4 pi and then 6 pi, and then this is going to be 8 pi, right? Now let's draw y is equal to negative 1 over 2. So if this point is negative 1 over 2, so if you were to draw the line, so find the points of intersection. So we've got 1 here, 2, 3, 4, 5, 6, 7, 8. So what are the number of solutions? So therefore the total number of solution is what? 8. And that is the exact, or I should say the correct answer. Alright, so we have achieved that because of our understanding of the sin x graph. Now the best way to gain mastery of this particular section is to do more questions. So that's exactly what we are going to do. Let's move on, students. Let's do another question, students. We are given secant 3x is equal to 2 with x being contained in 0, pi. Now we are expected to find the total number of solutions. So what I wish to do is I would like to write this as 1 over cos 3x is equal to 2. Therefore cos 3x is equal to 1 over 2. And the x is lying in the interval 0, pi. Now foremost what I wish to do is I know clearly drawing the graph of cos 3x is going to be an Herculean affair, so I don't want to tread on that. So what I would do is I would like to change the 3x into cos x or cos theta and then move on to obtain the solution. So before I could do that, I would like to extend this interval. So let me write this down. Cos 3x is equal to 1 over 2. Multiplying this by 3, I get 3x element of 0, 3 pi. So the interval is stretched. Next step is I would like to let 3x be equal to theta, and that would give us cos theta is equal to 1 over 2. And 3x is equal to theta. So this is going to be theta element of 0, 3 pi. Now if we were to draw the graph for cos theta, the graph would look something like this. So it starts here, comes down, then moves up, hits here, then moves up and hits down. So let's place the points. So clearly over here it's going to be pi. So this is going to be pi, this is going to be 0, and this is going to be 2 pi, and this is going to be 3 pi, right? And the interval is 0 to 3 pi, so it's enough that we go up until 3 pi. Now if I were to draw the value y is equal to 1 over 2, then the hit, if I were to hit, let me draw the graph, y is equal to 1 over 2, and find out the number of hits from 0 to 3 pi. So that would be, I get a hit here, that's 1, I get a hit here, that's 2, I get a hit here, 3, and this is beyond 3 pi, right? So there are 3 hits, that means there are 3 solutions. So you can write that down. Therefore the total number of solutions for this given question is how much? 3. And that is the solution for this particular question, students. Let's do this question, students. We've been given to find the number of distinct solutions of the equation 5 over 4 times cos squared 2x positive cos raised to the power of 4x positive sine raised to the power of 4x positive cos raised to the power of 6x positive sine raised to the power of 6x is equal to 2 in the interval 0, 2 pi. This is a lovely question. So foremost what I wish to do is I would like to consider the given equation. So this is the solution. Consider the given equation. So what is that? That is 5 over 4 cos squared 2x positive cos raised to the power of 4x positive sine raised to the power of 4x. I'm clubbing it as one term, and then cos raised to the power of 6x positive sine raised to the power of 6x is equal to 2. I would like to apply a formula which we have already studied. So if I were to apply that formula, this is cos squared 2x. This is going to be 1 negative 2 times sine squared x cos squared x positive 1 negative 3 times sine squared x times cos squared x is equal to 2. Now I can add 1 and 1 and subtract that 2 there. So that would mean I can cancel these terms and I can rewrite them as 5 over 4 cos squared 2x negative 2 times sine squared x cos squared x negative 3 times sine squared x cos squared x is equal to 0. I can add these two together. That would give me 5 over 4 cos squared 2x negative 5 times sine squared x cos squared x is equal to 0. So that is nice. Next what I wish to do is I would like to multiply by 4 and divide by 4. So this is going to be 5 over 4 cos squared 2x negative 5 over 4 times 4 times sine squared x cos squared x is equal to 0. I would like to have a 5 over 4, that's why I am just manipulating in this fashion. Now this is rewritten as 5 over 4 cos squared 2x negative 5 over 4. I'm going to write this 4 times sine squared x cos squared x as 2 times sine x cos x raised to the power of 2 is equal to 0. This is rewritten as 5 over 4 cos squared 2x negative 5 over 4. 2 times sine x cos x, that's going to be sine 2x raised to the power of 2 is equal to 0. 5 over 4 is common, I can take it out, so I get cos squared 2x negative sine 2x raised to the power of 2, that's going to be sine squared 2x is equal to 0. So I got cos squared 2x negative sine squared 2x, and I know a formula. What is that? Cos squared x negative sine squared x is equal to cos 2x, but in this case you got cos squared 2x. So I can rewrite this as 5 over 4 of cos 4x is equal to 0, which implies cos 4x is equal to 0, and we given x to be in the interval 0, 2 pi. Now as I mentioned to you, drawing the graph for cos 4x is not going to be an easy affair. So I would consider it in this fashion. I would like to stretch this interval. So I got cos 4x is equal to 0, and I multiply the x is actually x element, right? So x by 4. So now it's going to be 4x element of 0, 8 pi. So now the interval is stretched. So let me take 4x to be equal to theta. That would mean I now have cos theta is equal to 0, and theta is contained in the interval 0 to 8 pi. Now if I were to draw cos theta's graph 0, so it's going to start here, it's going to come down and move up, come down and move up, come down, move up, come down and move up and come down and move up like that. So let me mention these points, right? So this is going to be 0 and it hits the bottom. This is going to be pi. It raises up, right? So that's going to be 2 pi there. It hits here, it's going to be 3 pi. It moves up 4 pi, hits down 5 pi, moves up 6 pi, hits down 7 pi, moves up with 8 pi. So this is the point that we are looking for, right? So if I were to place in the intersection, cos theta is equal to 0. So there is an intersection here, over 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 here, and this is beyond 8 pi, right? So 1, 2, 3, 4, 5, 6, 7, 8. So total number of solutions, therefore total number of solutions in this case is equal to 8. So that is the end of this beautiful question, students. Welcome, students. We have been continuing our study on trigonometric equations. Now we are expected to solve this question. So we got 2 times sin x negative cos x of 1 positive cos x is equal to sin squared x, given the interval being 0, 2 pi. So foremost, what I will do is I will start off by considering the given question. 2 times sin x negative cos x times 1 positive cos x is equal to, I would like to write sin squared x as 1 negative cos squared x. After which I would like to write 1 negative cos squared x as 1 negative cos x multiplied with 1 positive cos x. On the left hand side I've got 2 times sin x negative cos x times 1 positive cos x. So if I were to move everything to the left hand side, I would get 2 times sin x negative cos x times 1 positive cos x negative 1 negative cos x times 1 positive cos x is equal to 0. I would like to take 1 positive cos x as a common factor. That would give me 2 times sin x negative cos x, and that is followed by negative 1 negative cos x times, and that has to be equated to 0. So this is further rewritten as 1 positive cos x times 2 times sin x negative cos x negative 1 positive cos x is equal to 0. Positive cos x negative cos x gets cancelled, giving us 1 positive cos x times 2 times sin x negative 1 is equal to 0. So from here I get 1 positive cos x is equal to 0 and 2 times sin x negative 1 is equal to 0. This is going to be cos x is equal to negative 1. So that would mean x is equal to pi, right? Which is obviously in the given interval, right? So this is one solution. The next solution is going to be 2 times sin x is equal to 1. Sin x is equal to 1 over 2. Now over here we will have to obtain the principal solution. So if I were to take the modulus, then the step 1 would be sin alpha is equal to 1 over 2, step 1. Step 2, find out the quadrant in which the sign value is positive. So if I were to take the representation CAST, all ratios are positive, sign alone is positive. So we want the value of sign to be positive, right? So that is possible only in the first quadrant and in the second quadrant. So the values for the first quadrant and the second quadrant, alpha, and this is pi negative alpha, pi positive alpha, 2 pi negative alpha. So we are looking at this point and this point.
So let me write that down. Now clearly in this case alpha is going to be equal to pi over 6, right? Pi divided by 6 is nothing but 30. Sine 30 is 1 over 2. So over here alpha is equal to pi over 6, that's one value. And next we will have to obtain pi negative alpha, which is nothing but pi negative pi over 6, which is 6 pi negative pi over 6, which is 5 pi over 6. So this is the value. So therefore the solution set is going to be, I got the following: pi over 6, pi, and 5 pi over 6. So all of this are in the region 0, 2 pi. So this is the solution for this question. Now you might be wondering, why have I not cancelled one positive cos x with the left and the right? Don't do that. If you're going to be doing it, you would not get this solution, right? This solution would be missed out. Of course, you can come back again and start assigning 1 plus cos x is equal to 0, but most would not go back in achieving this solution. So that's the reason, as a precautionary measure, don't cancel it. Just proceed with the solving the system and finally you extract the value. Students, let's solve this question. We've been asked to find the solution for this following question. So the question is as follows: find the general solution of the equation 2 sine squared 2x positive 6 sine squared x is equal to 5. So we are expected to obtain the general solution. So whatever solutions are there, you have to get the general solution. So what I would do is I will start off by saying consider 2 times sine squared 2x positive 6 times sine squared x is equal to 5. Now I would like to write this as sine 2x raised to the power of 2 positive 6 times sine squared x is equal to 5. I know that sine 2x is 2 times sine x cos x. That has to be raised to the power of 2. I get 6 times sine squared x is equal to 5. I can square them. I would get 4 sine squared x cos squared x positive 6 times sine squared x is equal to 5. Now I would like to use this part of the space. So 2 times 4 is 8, and I have sine squared x cos squared x positive 6 times sine squared x is equal to 5. Now let me rewrite cos squared x as 1 negative sine squared x. So this is 8 times sine squared x of 1 negative sine squared x positive 6 times sine squared x is equal to 5. So this is going to be 8 times sine squared x negative 8 times sine raised to the power of 4x positive 6 times sine squared x is equal to 5. I can add these two and get as 14 times sine squared x negative 8 times sine raised to the power of 4x is equal to 5. So this is what I've got. Now what I can do is I can actually push everything to the right hand side. So that would mean I will now have 5 positive 8 times sine raised to the power of 4x negative 14 sine squared x. So rewriting this, we get 8 times sine raised to the power of 4x negative 14 sine squared x positive 5 is equal to 0. Now I can factorize this as follows: 8 times sine raised to the power of 4x negative 10 sine squared x negative 4 times sine squared x positive 5 is equal to 0. I can take 2 times sine squared x out, that would give me 4 times sine squared x negative 5. 2 times 5 is 10 with a negative sign. That's going to get me 10 sine squared x with a negative sign, followed by, if I were to take 4 out, that would give me sine squared x negative 5. So I cannot take 4 out. If I were to take 4 out, I need to write this as 5 over 4. Then that would give me unwanted issue. So I can take negative 1 out. So if I were to take negative 1 out, this is going to be negative 1 times 4 sine squared x. That's fine. So negative 4 sine squared x is there. I need to get positive 5. So that would mean negative 5 here. So negative 1 times negative 5 would give me positive 5. So that's fair enough, right? So 4 times sine squared x minus 5, 4 times sine squared x minus 5. So I can take 4 times sine squared x minus 5 as a common factor, giving me 2 times sine squared x negative 1 is equal to 0, right? Now this would mean 4 times sine squared x negative 5 is equal to 0, and 2 times sine squared x negative 1 is equal to 0. From here, 4 times sine squared x is equal to 5, which means sine squared x is equal to 5 divided by 4. 5 over 4. This is greater than 1. So that means no solution. Okay, not possible. The solution cannot exist here because this value 5 divided by 4 is greater than 1. So we have to drop this. So this is dropped. Okay, drop this. So now we have 2 times sine squared x negative 1 is equal to 0. So 2 times sine squared x is equal to 1. So sine squared x is equal to 1 divided by 2. So I can rewrite this as sine squared x is equal to, I need to get 1 over 2, right? So I can write this as sine 45, right? Sine pi over 4, that's given me 1 over root 2. If I were to square it, I would get 1 over 2, right? So I can rewrite this as sine squared x is equal to sine squared pi over 4. This would mean my alpha is equal to pi over 4. If you remember our previous discussion in obtaining the solution, this is the way we actually explained in the process of extracting alpha. So that would mean the solution is going to be of the form, this means n pi plus or minus alpha. This is the general solution that we have obtained. So this would mean n pi plus or minus alpha is pi divided by 4, where n is an element of integer, right? So that is the solution for this beautiful question. So students, we will move on to the next question. Let's do this question, students. We are expected to find the general solution of the equation 1 negative tan theta times 1 positive sine 2 theta is equal to 1 positive tan theta. So this is what we have been given. So foremost, let us start off by considering the given system, which is 1 negative tan theta times 1 positive sine 2 theta is equal to 1 positive tan theta. Now we know a formula for sine 2 theta, which is 2 times tan theta divided by 1 positive tan squared theta, right? This is multiplied with 1 negative tan theta is equal to 1 positive tan theta. If I were to take the LCM as 1 positive tan squared theta, this would give me 1 positive tan squared theta positive 2 times tan theta. times 1 negative tan theta, right, which is equal to 1 positive tan theta. Now this is a perfect square, so I can rewrite this as 1 positive tan theta raised to the power of 2 times 1 negative tan theta divided by 1 positive tan squared theta is equal to 1 positive tan theta. Okay, so now we have two components. Now, as I mentioned to you, if you are going to be cancelling these two terms, you have to be a bit careful. What I'm going to do is I'm just going to cross multiply and bring the terms to the left. So this is going to be 1 negative tan theta times 1 positive tan theta raised to the power of 2 is equal to 1 positive tan theta times 1 positive tan squared theta. Let me bring these terms to the left, and that would give me 1 negative tan theta times 1 positive tan theta raised to the power of 2 negative 1 positive tan theta times 1 positive tan squared theta is equal to 0. Now 1 positive tan theta, 1 positive tan theta can be taken out, and that would in turn give me 1 negative tan theta times 1 positive tan theta. 1 positive tan theta is already taken out, so this is going to be negative of 1 positive tan squared theta is equal to 0. So this is further rewritten as 1 positive tan theta times, this is 1 negative tan squared theta, negative 1 negative tan squared theta is equal to 0. So positive 1, negative 1 can be cancelled, and this in turn is going to be 1 positive tan theta times negative 2 times tan squared theta is equal to 0. So this is what I've got. So from here I get 1 positive tan theta is equal to 0. This is going to be negative 2 times tan squared theta is equal to 0. Clearly tan squared theta is equal to 0. I can rewrite this as tan squared theta is equal to tan squared of 0, which would mean alpha is equal to 0, right? Because tan squared 0 is sine squared 0 over cos squared 0, and that's clearly would give me 0. So alpha is equal to 0. So the general solution in this case is going to be theta is n pi plus or minus alpha. So that would mean n pi plus or minus 0, which is nothing but n pi. So n pi is the solution. So let me write that out. Theta is equal to n pi. Okay, so for this part. And coming back to this part, in this case tan theta is equal to negative 1. Therefore I can write this as tan theta is equal to tan of 3 pi over 4. So clearly in this case theta is going to be n pi plus alpha, which is nothing but 3 pi over 4. So therefore the solution set, therefore the solution is going to be n pi union n pi plus 3 pi divided by 4. This is the complete solution for this question. So it's a lovely question, students.
To see the next type of trigonometric equations. So this type is of this form: a times sine x positive b times cos x is equal to c. Now if you get this form, instantly what you need to do, you have to divide by root of a squared positive b squared, and repeat that, a squared positive b squared over here root of a squared positive b squared. Now what is exactly this a over root of a squared positive b squared? So if you were to draw the right angle triangle and taking this as some alpha and this to be a and this to be b, this is going to be root of a squared positive b squared. Now sine alpha is a over root of a squared positive b squared, and cos alpha is equal to b over root of a squared positive b squared, right? So if I were to take this as say 1, let me take it as 2. Let 1 be a times sine x positive b times cos x is equal to c. So this is the original form, right? So therefore I can rewrite 2 to be as a over root of a squared positive b squared. That's nothing but sine alpha times sine x positive cos alpha times cos x is equal to c, which I can rewrite as cos x cos alpha positive sine x sine alpha is equal to c, which is nothing but cos of x negative alpha is equal to c. Okay, so this is a very important part. In fact, this is c over root of a squared positive b squared root of a squared positive b squared and root of a squared positive b squared. Okay, so we can't miss that out. So having given you this, let me head on to do related questions of this type. Students, we are being given this question: find the general solution of sin x positive cos x is equal to root of 2. Now foremost, what I would do is I would consider the given question, which is sin x positive cos x is equal to root of 2. Now this is of the form a times sin x positive b times cos x is equal to c, where a is equal to 1, b is equal to 1 and c is equal to root of 2, right? So what did we do? We just took the value of a squared positive b squared and we divided it throughout. So that's going, in this case, is going to be 1 positive 1, which is equal to root of 2. So we will take this value and divide the entire quantity by this root 2. So this is all for your understanding. You don't have to write this as part of the solution. Just keep this at the corner of your mind. So this is going to be 1 times sin x positive 1 time cos x is equal to root of 2. And I would divide this by root 2, divide this by root 2, divide this by root 2. Now clearly root 2 can be cancelled. Now I got 1 over root 2 times sin x positive 1 over root 2 times cos x is equal to 1. I would like to write 1 over root 2 as sine pi over 4 times sin x positive cos pi over 4 times cos x is equal to 1. I can rewrite this as cos x times cos pi over 4 positive sin x times sin pi over 4 is equal to 1. So this is nothing but cos of x negative pi over 4 is equal to 1. I can further rewrite this as cos of x negative pi over 4. It's 1. I can instead replace 1 as cos 0. Now this is of the form cos x is equal to cos alpha. So that would mean x negative pi over 4 is equal to alpha is 0 degrees, right? So the solution, so instead of just going like this, okay, we will have to write the general solution. So therefore the general solution, I don't have to specify this, the general solution is going to be 2n pi plus or minus alpha. This is the general solution for this. So in this case my alpha, okay, so the alpha is 0 degrees here. So on the left hand side we are going to have x negative pi over 4 is equal to 2n pi plus or minus 0 degrees, right? So this can be further rewritten as, let me use this space. So if I were to push this pi over 4 to the other side, I would get x is equal to 2n pi positive pi over 4. So this is the general solution where x is element of z.